All right, y'all. So today will be 7.5, analyzing graphs of quadratic functions. So quadratic, I can make squared terms at the highest degree in there. But y'all should know that those x squared terms all make nice little parabolas for us, right? So we're going to play with that parabola today, okay? So we're going to look at what we call the vertex. So on a parabola, the vertex is going to be the minimum or maximum point of the graph. All right, several things this vertex does. It's the minimum or maximum point on the graph. If the x squared term is positive, then we will have a minimum, so it'll look like a U. So then we have a minimum. If x squared term is negative, so remember we learned 7.1, if we put negative in front of that equation, it flips the graph over to x-axis. So that means that this will have a maximum value. So x squared term positive is going to look like a U. If that term is negative, it's going to flip it over. Okay. Now this vertex is the point also that cuts my parabola in half. So the x coordinate is what will give me what we call a line of symmetry. Now we looked at symmetry on the y-axis. Remember, if I took the y-axis and folded my graph over, it landed right on it. So we knew it was symmetric to the y-axis. So these parabolas, they're going to be moved around. So we look at the x coordinate on that vertex as an imaginary line that cuts it in half. So the x coordinate of the vertex gives us the line of symmetry. In the form of x equals a. So when they ask you for the line of symmetry in MATLAB, they don't just want that number. They want the whole equation, like x equals 5 or x equals -5 on those, okay? Remember, where a is the x value of the vertex. So x value gives me the line of symmetry. The y value of the vertex gives me the maximum or minimum amount. So this would be your min or max. And like I said, it's equal to the y value. Okay? So this is equal to the y value of the vertex. So on these problems, we'll find the vertex, we'll find that line of symmetry. Then it's going to ask me, do I got a minimum or max amount? Well, I'm going to look at that x squared term to determine if it's a min or a max amount. Then it'll say the amount, and then that's going to be that y value, okay? All right, so we got a nice formula to find the vertex. So here we go, vertex formula. Now remember, vertex is a point on the graph, so it's got to look like an ordered pair when you actually put that vertex in that math lab, okay? To find the x-coordinate of the vertex, we use negative b divided by 2a. So I'll tell you that negative b divided by 2a is part of your quadratic formula. So with the quadratic formula, what it does is it takes that vertex, and then the stuff in the radicals, it'll add and subtract from each side to find them zeros, okay? So we don't have to know all that. We just need to know that negative b over 2a is going to find me my x-coordinate. To find the y value, we take what we got from the negative b over 2a and plug it back into the function, which means we're finding f of negative b over 2a. And that'll give me my y value. So we find our x, plug it in, that's going to give me the y value, okay? All right, so let me see. They're giving me f of x equals x squared minus 14x plus 40. So this will start about number 2 on y'all's homework. Number 1, they gave you a picture and they labeled a point, and they just wanted you to write it out as a vertex point, and then the symmetry, and then minimum or max value. But we'll do that on this one using an equation, okay? So I'm going to find vertex line of symmetry or axis of symmetry. I'll find if it's got a minimum or maximum. That value of the min or max. And then finally, it's going to want me to graph it. So, vertex formula is sitting right here. That's the main thing I'm going to use. So on this, I need to figure out A, B, and C, and it's just like the quad formula. A is the x squared term, B is the x, and then C is that number. So let's see, I know my A is going to be 1 since there's not a number there. B is a negative 14, and C will be a positive 40. See y'all on that? And basically, all done now, we're just plugging these in and getting my x and y values. So let's find our x coordinate first. To find the x coordinate, I've used negative b divided by 2a. So y'all be careful on this one because that negative is always in the formula. So you got to write that negative and then put in your negative 14 and divide that by 2 times my a, which is 1. So it's almost like you plug into that quad formula. Except we don't have all that radical stuff to worry about on this one, okay? So we'll simplify this, get my x value, and then we're going to plug it back into this to get my y value, okay? So negative negative makes that a positive 14. 2 times 1 gives me 2. And then I can do what? 14 divided by 2 gives me 7. So I know the x value on my vertex is going to be 7. So now, let's get the y value. So this says to get the y value, you find f of that negative b over 2, 7. So I'm going to be finding f of 7 because that's what my negative b over 2y equals. Okay? So y'all, I'm just going to plug a 7 in for these two x's and see what that gives me. So it's going to give me 7 squared minus 14 times 7 plus 40. So let's see, that's what, 49 minus 98 plus 40. Now, can I tell y'all a trick at this point? When I'm finding the y value and I plug them x's in, this second term here is always double that first term. And it always works out that way. So when you're plugging into this, that's sort of the way I check. Now they might have different signs depending on that x squared, but they're always double each other. Okay? And I love that because when I do 49 minus 98, I know it's going to be a negative 49. I don't even have to break out a calculator notes, but I know they're like double each other. So 49 minus 98 is a negative 49 plus 40. So negative 49 and 40 gives me a y value of negative 9. So my vertex is going to be an ordered pair when I get a 7 and then a negative 9. That's what MATLAB needs, is that in them parentheses, okay? All right, so my pattern on vertex is just plugging them in and getting the x and then plugging that in and getting me a y value, okay? Almost like that GMS stuff, right? We have to take the equation and plug them in. So next I wanted to find the line of symmetry. The line of symmetry is going to be x equals the x value that I got on that vertex. And my x value was 7. So my line of symmetry will be x equals 7. Next is asking, do I have a min or max? Well, for min or max, I'm looking at what sign is my x squared term. If the x squared term is positive, I got a minimum because it looks like a U. If the x squared term is negative, it flips it over and gives me a maximum. Well, mine's positive. So since mine's positive, I got a minimum. And I'll write that here. That's because since the x squared term is positive. Okay? Then it asks me, hey, what's the value of that min or max? Well, we said that's a y value, right? So the min or max value would be the y value, which is negative 9. So that means on the y values, my graph came down, got down to where that negative 9 is, and then it started shooting back up, okay? All right, what was left? They want us to graph this. Oh, mine's going down 9, so I better go back 10. So really, when you graph this, the first point you're going to plot is that vertex. And then you got to find 2 more points to use on that, okay? So the easy thing to do is just graph it on that calculator. Graph that function, the x squared minus 14x plus 40. And then you can use your table to get 2 more values. Or you can find 2 zeros like we learned Monday on those, okay? So when I graph it, I'll probably just find me 2 more zeros, okay? So I do know that one point on here is going to be over here at 7, negative 9. That's my vertex, okay? So I'm going to find, I need 2 more points. But remember, if I can find the zeros, I know where it's crossing the x-axis at, okay? So I'm just going to set this equal to 0. Now, I will say this. For me to use zeros, I want them to be factorable. I don't want to try to plot stuff that's got radicals on it. Because where is the square root of 2 on a graph? Right? We could estimate it, but we won't get there. So if they don't factor, then I'll probably just plug in numbers and see what 2 numbers I would get. Okay. So let me ask y'all this. Does this one factor? Can I find factors of 40 that'll equal 14? So I'm going to start going out. Now, since that last sign's positive, I know both of these factors will be negative when I factor it. Okay. So a negative plus a negative is a negative times a negative is a positive. So y'all, what factors of 40 will add to give me 14? Oh, we do this in Arkansas, y'all. Multiply to get a 40. What do you want to multiply? What's the most popular way to get 40?
Oh, 10 times 4.
10 times 4, which adds up to get 14. There you go. So must be early on y'all, right?
Yeah.
That's only 10, 19 members, not 11. So 10 and 4. Now, money we learned once we got it factored, we set both of them equal to 0 to get them answers. So let's see, here I'm going to add 10. So 1 0 will be at 10, so that means 10 on the x-axis. I'm crossing it right there. Here I would add 4. You get x is a positive 4, which means it's 4 on this x-axis. I'm crossing right there. Now remember, when you do math lab, you got to plot this point first. Then when you plot this point, it'll sort of draw a line. But then when you come to this side to draw this point, it'll make it a parabola. So it takes 3 points on these to get that parabola drawn. Good. Something like that. So now, y'all, this line of symmetry would have been over here at x equals 7. So at 7, that's where it would have cut my graph right in half and made it symmetric to itself, okay? And then here's that minimum y value of -9, which is the smallest value on my graph, okay? So they're not too bad, are they? But y'all, if y'all got my program, y'all got my vertex program in there, in that calculator. Punch in ABC and it'll kick them out, right? All right, here we go. F of x equals 2x squared plus 10x plus 15. Same thing, right? Find me the x value, then find me a y value. So I'm gonna get the x value first, which is negative b over 2a. All right, let's see, I got my negative, and then I put my b in, which is a 10. That's going to divide by 2 times my a, which is a 2. I sort of like this one because y'all love fractions, right? Well, unfortunately, I'm going to get a negative 10 over 4. So that does not divide, but it will reduce. So I can divide both of them by what, a 2? And so that'll give me what, a negative 5 over 2. So you're going to get one at least a fraction, okay? So now put that negative 5 halves in for them 2 x's, and let's get that y value. So for my y value, I'm finding f of a negative 5 halves. So that'll equal 2 times x squared, which is a negative 5 halves squared, plus 10 times a negative 5 halves, plus 15 at the end. So y'all, we gotta get the exponent first. So we need to get this negative 5 halves squared. When you square a fraction like that, multiply the top times top, bottom times bottom. And a negative times a negative, we'll make that a positive, okay? So square root of 5, 5 times 5 is 25. Square root of 2, 2 times 2 is 4. And y'all, I'm just going to bring everything else down. So now I'm going to multiply to see what I get. So let's see what I get here. Remember, treat these like they got ones on the bottom when you multiply by a fraction. So 2 times 25 would give me 50 over 4. Positive times a negative here, so that's going to make this one what? A negative. 10 times 5 is what? 50 on top. 1 times 2 is 2 on the bottom. So that gives me a minus 50 over 2. And then at the end is my 15. So I'm going to put a 1 under this 15 to make it look like a fraction. Now the calculator will add this and give you fraction answers. But by hand, if you want to add this, you want to have a common denominator. And I do know that the LCD between a 4, 2, and a 1 is that 4 down there, okay? So I'm going to turn all these into a 4 on the bottom. First one already has a 4, so I'm going to bring down that 50 over 4. Minus. All right, the second one has a 2 on the bottom. To turn the 2 into a 4, I would multiply by 2, which means the top gets multiplied by 2. So that I get a 100 over 4. Which y'all remember at this point, ain't that one double now? But once you get it down to the simplified state, that second one will always be double that first one. And at the end, I got plus. To turn the 1 into a 4, I got to multiply by 4, which means I got to multiply that top by 4. So that one will give me, what, a 60 over 4. So y'all now just what, add those up and see what we get. I know 50 minus 100 is going to be a negative 50. Negative 50 plus 60. So basically, that's what, 60 minus 50? That's going to give me a 10 on top. Common denominator just sort of slides right on over to give me a 4 on the bottom. But hey, want that 10 over 4 reduced? So this will reduce, because both of them again will divide by a 2 on this one. So that my y value is going to be a 5 over 2. So that my vertex, so let's see, what was my x value? My x was a negative 5/2. My y value was a positive 5/2. You know, I think my vertex formula I gave y'all will actually spit it out as a fraction. So go down to vertex on that thing. Go program and then all the way to vertex. Should be the last one I gave you. Hit enter a couple times to get it started.
Okay, I'm at vertex.
Hit enter and it'll start. There should be a question mark there.
Mhm.
So put your A in, which was my A was what, a 2. So put your 2 in. Then ask for B, which was 10. And then C, which was 15. So calculator gives you negative 2.5, turn that into a decimal or fraction, and then a positive 2.5. So to turn them into fractions, all you got to do is go 2.5 on the calculator and hit math and fraction, and it'll turn it into the 2/2, okay? I think that's the only one you had to worry about the fractions on. So let's see, what else I need? Got my vertex, so my line of symmetry. And I think if you're doing homework, don't they actually call it axes of symmetry in there? I'm pretty sure they call that axis of symmetry. It's the same thing. Would be x equals, well, what was my x value? My negative 5/2. Once you got these two numbers, you got everything you need for this problem, okay? Other than the graphing part of it. So line of symmetry, so here, then I got a min or max value. So to find out if I got a min or max value, I'm looking at this x squared term. Positive, I got a minimum. Negative, I got a maximum. Well, that 2x squared is positive, right? So we got a minimum. And the minimum amount is the positive 5/2. Okay. So I won't try to draw something in halves on the board, but it'll be split into halves on that graph when you start doing it, okay? They'll break it down to like 1/2, 1, 1.5, 2. So it'll be, instead of going by ones, it'll go by 1/2. Okay? All right, let's see. I'm gonna start right here. All right, same thing. F of x equals negative x squared minus 4x plus 2. Oh, and I'll probably have y'all for 30 minutes on Friday, okay? Just to make sure I don't want to rush through this. I like sort of taking my time with this class, so probably about 30 minutes all it'll take is Friday. All right, so let's get that x value first on that vertex. X value is going to equal negative b over 2a. But you got to be careful on this one because it's going to have negatives everywhere. So we write the negative, put in my b, which is a -4, divide that by 2 times my a, which is a -1. All right, so let's see, it's going to give me a +4 on top over a -2 on the bottom. And 4 divided by -2 gives me a -2. So the main thing that gets people on this is they forget to put a 1 there. They treat it almost like a 0 sometimes. So there's got to be a 1, okay? All right, to get the y value, we're going to plug that -2 into that equation. So I'm going to find f of -2. So y'all be careful, because I got to write this negative down first. Then put in my -2 and square it. Then I'm going to put in the -4, and for that x, I'm going to put a -2, and then at the end is my +2. Usually where I get people on this is they see this minus right here, and just put in a -2 instead of including that minus that was in the formula, okay? Also, I get some of y'all doing this. That negative and negative ain't making that a positive. Because multiplying don't have priority over no exponent, right? So you bring that negative down, because the first thing you're going to do is the exponent. What's the -2 being squared? So -2 times -2, +4. So you see what happened? That's going to stay negative. Okay? And I'll tell you the truth. Anytime you got a negative in front of an x squared, that term will be negative. Because anything I squared is going to be positive. And that positive times that negative that's sitting out there is going to keep it negative, okay? All right, so right here, subtracting 4 times a -2 will make that a +8. And then I got a +2. So notice, although the signs are different, that second one is still twice as big as that 4 was, okay? All right, y'all, so my y value is going to be -4 plus 8, which is 4. 4 plus 2 is give me what, 6? So my vertex is going to be -2, comma 6. So then I want so the book I think calls it axis of symmetry. It's going to be x equals one of them numbers, right? So I usually remembered it because of x equals, I always knew it was the x value, right? So when I get a -2 for my x value, then it's asking me minimum or maximum. I'm looking at the what, x squared term, which is sitting right here. It's a negative this time, right? Which means it flips it over, and I don't have a minimum, I got a maximum. And the maximum value is? Six. There you go. So see, I always knew it's like, okay, I got 2 numbers here, and I know the x is going to be the x one. So the only choice would be the y value for that min or max, okay? I'll probably make a good bonus for this one just to shoot out at y'all one night. I do one of these like with a pin. You got so much fence to make a pin out of. What sizes do you need to make it to get the maximum area and stuff like that? One of them challenging problems, right? All right, y'all, this is from information we've learned this second test, okay? True or false for these? So this is going to go back really to the 7.2 stuff where y'all are moving them graphs around. So they want to know the graph of h of x equals x plus 2 squared can be obtained by translating the graph of h of x equals x squared, right 2 units. Is that true or false? So this goes back to looking at they're saying left or right, so they're looking at the horizontal movement of this graph. So when y'all are looking at these, and we've seen something like an x plus 2 squared, that plus 2 is actually going to move me to the left. So remember, on the horizontal, it's sort of backwards what you think. When you add, you're actually moving it left. When you subtract, you're actually moving it right. So they're saying, hey, you can translate the graph right 2 units. That is definitely false. Okay, because remember when we did the 7.2, we said if this was added, A being added, it's going to go left. If it was being subtracted, it would go to the right. All right, so another one on that line, true or false. The axes of symmetry of the function f of x equals -9 times x plus 8 squared plus 4 is at x equals -8. So really what you want to focus on, parameters usually start at the origin at 0, 0. What is that plus 8 doing to my graph? Remember, since it's positive, it's actually moving it left. So if you started at 0 and went left 8, you would be at x equals -8, which would be the center of my graph, which means my line of symmetry would be at x equals -8. So this is definitely true. So they just want you to focus on which way are them numbers moving my graph. Okay. Right, so the next one has a lot of stuff. It's got range and everything. All right, so on this one, I'm going to find vertex, min or max value, and that value. So I'm going to tell them if it's a min or max to find that value. I want to find the range. Intervals on which it is increasing or decreasing. For the increasing and decreasing, you want to read that graph left to right. All right, so here we go. We got an f of x equals x squared minus 10x plus 24. Now, I'll actually probably graph this one just to get y'all a picture of what's happening with it so that you can see what I'm doing when I do the increasing, the decreasing, and the range stuff. Because we ain't done much range in here, okay? First thing is that vertex. So I'm going to get that x coordinate, then the y coordinate. X coordinate is negative b over 2a. So that'll be a negative. My b is a negative 10 divided by 2 times my a, which is a 1. So you notice that negative b, all it does is change the sign of whatever that b is, whether it's this formula or the quad. Okay? All right, so that looks like what, a 10 over 2, which will give me a 5. So I now know the x coordinate is 5, so I'm going to get the y value by finding f of 5. So y'all just put our 5's into here. I got 5 squared minus 10 times 5 plus 24. So y'all watch this. I know this one's 25, I automatically know that's going to be a 50, right? So I got 25 minus 50 plus 24. So 25 minus 50 is a negative 25. Negative 25 plus 24 is what, a negative 1? So I now know my vertex is going to be 5, comma, negative 1. So I'll hit y'all with this question. Do I have a min or a max? Min or max?
Min.
Min, because that's a positive x squared, right? And all we had to do was look at this x squared right here. Since that was positive, it's definitely a minimum. And the minimum value is going to be the y value, which was the negative 1. Then they want my range. So y'all, let me show you what's going on with this. I don't know where it's going to cross at the moment on the x-axis, but I do know, sitting over here at 5, at the moment, I know sitting over here at 5, negative 1 is my vertex. And you told me this was a minimum, right? So I know this vertex is going up somewhere. So it's wanting me to find the range. The range is all the y values. And let me see what they want this in interval notation. So what's the smallest y value I can equal? So remember, here's my y's, right?
Oh, negative 1.
It's got to be negative 1. So the smallest y value is going to be negative 1. And we use brackets for that because it can equal negative 1, okay? So if it can equal that number, you put brackets. If it's greater than or less than, then you would use the curvy ones. So here you go. You start at negative 1, and your range is headed towards infinity. Ooh, good job. You're on the ball with that. That's what we like. And infinity always has a curve. Because you can always go one bigger, one bigger, one bigger, one bigger forever. Okay? So focus on the range being the y values, not the domain x values, okay? Now, for my intervals of increasing or decreasing, I will look at x values. So I'll do the increasing first, and then I'll do the decreasing. So notice, increasing left to right is where this graph is going uphill. It's always going to start at this vertex here, because that's where it's cutting my graph in half. So on the x-axis, my graph starts increasing at 5. Remember, x-axis. So we start increasing at 5, and y'all increasing and decreasing, always use curvy parentheses. Because that 5 can't be both, right? It can't be the increasing and the decreasing point. So we always use the curve, because it can get right up to that 5, and then 5 is where it would sort of be the crossover point, and then it's going to shoot up. Now from 5, this graph is increasing until it hits infinity. So then we got what? Decreasing. Well, decreasing is this part of the graph going downhill. I know where it's going to end, so where's it starting at over here? It's coming in, decreasing on these axes. Not positive infinity, but negative infinity. And you just got to remember, those intervals got to be written from left to right on these graphs, okay? Because time moves forward, not backwards, okay? And then it stops decreasing at x value of 5. There you go. So you'll notice when it's a parabola, the beginning and ending got to be the same on those, okay? Okay, so I'll break out probably 1 or 2 more of these problems, and then I'll go over the toy rocket being shot in the air, so we can find out what was its maximum height and how long did it take to get to that maximum height. Okay. So what affects things when you throw them in the air? Gravity. So these formulas we look at Friday, the toy rocket one, it takes into account gravity and stuff like that. Okay. All right, so any questions, y'all? Not too bad, vertex stuff. Next, we start getting into more domains on radical stuff and playing with them next week. But Friday, I'll knock out the rest of 7.5. Like I said, it won't be, but probably 20, 30 minutes on a Zoom Friday at 10. And then y'all be ready to go. Remember, test 1, if you're redoing it, is due Thursday night by midnight. If you redo it and you don't do as good, don't worry, it'll take the best test of the 2. Once those tests are completed, then I'll look and see who sent me bonus stuff. Okay. All right, y'all. So y'all hang online just for a second. I got to get a few more of y'all. So I got Taylor, Peyton, Toya, Thomas, and Sydney. Let me write them down. Hold on, let me, let's see. Alabas?
No, that's not.
Oh, Ernesto. Okay, I got you. You're not okay. All right, y'all have a good one. Got Owen, Taylor, I got. All right, looks like I got all y'all online, so I'm going to stop recording and send this video out in a little bit. Friday, I'll be on for about 30 minutes. So I'll see y'all Friday.
All right, see you.
All right.
Thank you.